Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. It's nice and sunny outside. We haven't made an example video for a while, so I thought why not. So what we're going to be doing today is kind of a playoff from, or a spin-off rather, from what we did in the last video, which was copy constructors. So the reason we used copy constructors was that these pointer variables in our classes don't get shallow copied. Now you go and watch the last video if you don't really know what that means, but I'll go ahead and explain it quickly in this video anyway, just as a repetition. But shallow copying just means that you don't copy over the actual memory and give the new object its own memory space. Instead, you take these pointer variables and you just directly assign them to the other objects' pointer variables, which means that the addresses will be the same, which means that these two objects will have the same memory location. So if you change one object, you'll be changing the other one's pointer variables. So we don't want that. So let me just go ahead and make a little dice class, because that's what we're going to be working with. We're going to need since we're cool and we never just make a example program, we're going to be making, well, what am I saying? We just don't show code, we actually make an example program. So what I'm going to do is make a vector full of dice, and I'm going to roll them because that's cool, and that's at least going to give us something. And then what I need is include ctime. Now somebody in the comments told me that C++11 has its own random stuff. I'll be learning that, of course I will be. I haven't been doing that, working with that for a while, so I'm not really sure how to do that, but I'll go ahead and indulge myself, what do you call it, and I'll learn all the random stuff. But anyway, let's make a dice class if I can remember C++. Why are you even here, guys? I'm not sure if I even remember how to code. I'm just kidding. Stay private, and then I like my public parts beneath and my private parts above. And then I'm just gonna go ahead and make a little integer pointer, call it value. So the dice is gonna have its max value, right? And then I'm gonna make a little dice constructor, which is gonna take an int value, and we're just gonna go ahead and make this value equals value. Bam, we got ourselves a constructor. Now you need to do this. Whoops, new integer, sorry about this, new integer value. So we make a new memory location, which we then copy this value integer into, or that what do you call it, the actual number from value, or this value here, we copy into this new integer we created. Now we need a destructor because we are using new, so we're gonna have to just go ahead and delete this value. The reason we can just go ahead and delete this without any checks is that we make sure that we're actually not leaving this pointer without any values. Now if we just left it like this and deleted it without doing anything with it, not even making it to null pointer, we'll get a crash. So just make sure you always do something with your pointer. Have a variable in it, put it to null pointer, or do something before you delete it like this. So yeah, just do that, otherwise you'll get a bunch of crashes. Now we're gonna make a copy constructor. Now if you remember from the last video, what you did was you did dice, and then in the parameter list what you do is you take another dice object. So dice, or you do const dice object. Doesn't really matter where you put this, I like to put it here. You do that. Now this means that it'll take in another dice object when it's creating. So the constructor means that you can only call this when it's being created. It will either call this or this. Now it's calling this because it senses that, okay, we're creating one dice object with another dice object, which is already defined, or a temporary dice object, or whatever. The assignment operator overload will be used when both these dice objects are already been created some other time in the program, and we're actually assigning them to another dice object or to each other or whatever. So yeah, that's why we need the two different ones. So what this is going to do, this is going to do the same thing as the other constructor is doing. value equals new int value, or no, whoops, new int object dot value. Basically the same thing. It's just that it's now we're actually taking the other object's value here, and that's it. And to make the operator, what you want to do is you want to just make it void as a return type, make it operator, and then your operator you want to overload. You can overload any operator almost, you know, any kinds of things, and you could even the cout and cin operators you can overload. So this is going to be a const dice object, just like the copy constructor. And we're just gonna not make a 7 there. Actually, we're gonna do that, and from here on it's a little different. Now what do you want to do is you want to delete, the voice crack, delete this value first, because these two objects already exist. Now if we just point the object's value to the other object's value, just like that, it already has its own value, the original object, and it's just gonna be pointing to the other one if we just leave it as a default. Now that's why we specify these two things here, though, the copy constructor and the assignment operator overload, because we want a specific behavior from them when this case occurs. So delete this value, and then we'll say this value equals new int object, whoops, dereference it, of course, because we want the value, not the address it's at. Object dot value. Bam. Okay, so now we have a working dice class with all of this fun stuff. What we're gonna make more now is we're just gonna do functions, and we're gonna functions main. There we go. We're gonna be doing a role class where it's gonna return. We'll just do inline const int reference get value. That's what we're gonna do because we're lazy, and we'll just return this value, and of course dereference it. Why didn't I do that? There we go. Oh, the voice crack again. Oops, sorry about that. So yeah, get value. That's all you need. Yeah, that's cool. So we'll be able to kind of roll this dice. But yeah, that's all we need. Now I thought I'd illustrate this for you, tell you what is going on. And you can skip this part if you're kind of sure what's going on. But let's say we have a memory location here, or a piece of memory, right? And we have our slots here. I'm just gonna make them a little bit weird. Okay, we have created one dice object, and we create another dice object, and we say that the value pointer here is empty, or we will give it a value pointer equals new int, let's say 20. Okay, this is what happens. Equals new int 20. No, 10. Okay, so what's gonna happen is that this is D1, this is D2, by the way. Let's make this value pointer is gonna make a new slot in memory. This is gonna make a new slot in memory here. So what we get in here is we get 10 as a new integer, and we get 20 as a new integer. This is what happens when we make a dice regularly, 2 new dice. Now say we hadn't made these copy constructor thingies and the operator overload here. What would happen if this case occurred? So if we said D1 equals D2 somewhere in the program. Okay, now remember, these have already been defined before. Let's say we already made a dice D1 10, and then a dice D2 20. We already wrote this somewhere. Okay, now I don't want that to happen. We already did this somewhere. Okay, I'm getting OCD, but I'll just put one over there. Okay, whatever. This is what is gonna happen. Now, what you think is gonna happen if we don't have our operator, or the operator overloaded? Excuse me. So what happens then is that we're gonna be able to put D1 to D2. So you think this value is gonna change to 20? Nope. what's gonna happen is that this pointer, because we're the what do you call it, the default operator that C++ uses, just does a equal to in everything, okay, or assigns from the left to the right on everything. So what's gonna happen is we're gonna get a value. We're gonna d1 dot value equals d2 dot value, and remember these two are pointers. So what's gonna happen? We're gonna be giving them the addresses from this pointer. It's gonna give it its address and put it into d2, or d1 is gonna get d2's value's address. So the thing that's gonna happen is this pointer is gonna be pointing here. Bam, bam, bam. So this is just for the assignment operator. See, now it's gonna be pointing here. Now anytime we change value, the reference value, and change it, it's gonna be changing 20. And the same thing for d2. What we want is d1 to have its own memory location still and make this 20. So how do you do that? Well, you make your copy constructor. First thing we're gonna do is delete this. We delete this. So we deleted the pointer. Okay, it's not pointing to this anymore. And then we'll make a new int. Okay, it's gonna be making a new int. It doesn't have to be here anymore. It might find another place in memory. So it might find this place in memory. It's gonna make a new integer with the value from d2, from the object we're assigning from, or whatever you want to call it. So it's gonna be 20 now. Bam. That's what we're gonna do. That's what our assignment operator does. Overloaded. Now our copy constructor, if I didn't illustrate it before, that is a different case. It's the same thing, but it's a little different case, because this might be then in that case we don't have a d2 yet, for example. Okay, we don't have a d2. We have a d1, and it has a value of 10 still. Now when the copy constructor is called is only when an object is created. So when we make a new object, dice d2, either you write it like this with a parentheses d1, or you write it like this. It doesn't matter. Even if you're using the assignment operator, it's still going to be using the copy constructor, because you're creating an object from another object. So you want to do this d1. That's the thing that happens first. So what's going to happen is we're going to be getting a dice object called d2. Now again, what happens if we haven't specified this specific behavior here? This value equals new int object value. What's gonna happen is our object's dice2, or the d2 value, is gonna be directly assigned d1's value. So it's gonna be getting that pointer directly. Now as a new object, it might want its own little space in memory, but nope, it gets this space in memory, and that's gonna make it a lot more complicated for you to handle any kind of programming. You might just quit programming altogether if you don't know how to do this. So what you want to do is you want to get this specific behavior, and we don't use delete this value here because we know that dice2 is going to be a new object created, so it doesn't have an old value, and this is going to be getting its new value, and we might or we might not do anything else with it because it's going to get d1's value. So 10. Bam, boom, bam, we're good. So I hope this illustrated it for you well, why we're using these. And yeah, that's about it. Now we're gonna go ahead and test this a little bit. So go ahead and make a dice d1 and give it 10 like I said, and then we're gonna make a dice d2 equals d1. We're gonna see if this works. Okay, now system pause, of course I need that, and we're just gonna see out d1 that get value, and a new line just like this. I'm gonna cheat and copy paste this again just like this, d2 that get value. Bam. So we're gonna see if this works. They both should have 10 now, if I haven't screwed anything up. I don't think I screwed anything up. Nope, 10 10. Now if I set the value, let's see, let's do a inline void set value int value, this this value equals value. So I can manipulate the values. Now if I would set, now we know that it would be 10 after our first run, so d2.set value 25, and then we're going to print this out. Now d2's value here should be 25 and d1 should still be 10 because they're not pointing to the same memory location, like you can see here. That's perfect. Now our copy constructor works, and as I said, you can write this like this as well, and you'll get the same result. You'll get the same result. 10 10 exactly. So it doesn't matter, as the object is created, whatever thing you use, it won't matter. It's still gonna use the copy constructor. Now after these two are defined, say that we had another dice d3 and we gave it the value 40, just like this, and we said d2 equals d3. Now it's a different case because both of these objects have been defined, they have their values. Now d2 has an old value, but it has to take the value of d3, so it's going to have to delete its old value, and it's going to be calling the assignment operator. So this should give d2 a value of 40, and d1 should still be 10. Yep, exactly. And d3 should be its own set value 55, should be its own little thingy here. So I'm just gonna go ahead and do this. d3, bam. Oops, I burped. 10, 40, 55, exactly. So everything is working. They have their own space and memory. We're not getting memory leaks probably because we have delete going everywhere. So that's good. Now let's just make our cool little program here to make a bunch of things. We'll be using the copy constructor in here because we're cool. So let's say vector dice. Now there's no real reason for doing this, but it's fun, so I'm going to be doing that. Maybe you'll practice vector a little bit. Dice, no, let's say we have 20, bam. So we'll make 20 dice. So dice dot pushback dice. This is going to be using the copy constructor because we're making a dice object in this dice vector, and we're copying this thing I'm writing right now, this dice thing here. We're copying the values from that into another object that's being created in dice. So dice, let's say we make it with a, or we're gonna need random by 20. Let's say 20 plus 1, so we don't get a bunch of zeros, just like that. Now what I need to do is I need to initialize srand times 0. Bam, we're good. Okay, so we got a bunch of random stuff. Now this is gonna just make random dice, and it's going to push them back with a random value. And yeah, that's cool. We'll just make a quick little function here. Inline const int, just say int toss, and then we'll just do return rand this value plus 1, and just like this, and we'll just toss them a bunch of times. Now they have different values, and we'll just say cout toss cout dice at position I dot toss, because it's going to return an integer. I think this is going to work, I'm not sure. New line. So this is cool. Or we'll just make a bunch of dice with 20 as the max value, and then we'll just toss them all and print that out, and then system pause, and all kinds of fun stuff is gonna happen. So let's just make this quick, something fun to do. Yep, it just tossed all kinds of stuff everywhere. Bam, bam, bam. Rand is working, I think. Yeah, it's working. We're getting different values. One more time. Bam. Okay, cool. If there's a 12 in the bottom, I'm the best. Whatever, nobody saw that. Okay, cool. Thanks for watching, guys and girls. I hope you learned something today about assignment operators and overloading them. And we'll be talking about other operators soon, overloading them in your classes, making all kinds of addition and incrementing and all kinds of stuff. We're going to be having a lot of fun. So keep learning, take care, and as always, just thanks for all the support and stuff, and I really appreciate it, and it really helps me out. It really feels good to help you guys out with any little programming knowledge that I have. So yeah, take care, keep learning. I'll see you in the next video. All right, so bye bye.